Richard uses a rope to pull a crate of mass 20 kg up along an inclined plane of 30 degrees. The tension in the rope is 147 newtons, and the coefficient of kinetic friction between the crate and the inclined plane is 0,1. We have to calculate the acceleration of the block. Use this strategy now to actually put in numbers at the relevant places and answer this question. Pause the movie until you've done that. The object is in equilibrium perpendicular to the slope, and therefore the normal force is equal in magnitude but opposite in direction to weight's perpendicular component. In other words, it's equal to weight multiplied by cos 30 degrees. Weight is 20 times 9,8, so the normal's magnitude is 20 times 9,8 times cos 30 degrees, which is 169,74 newtons, and we know the direction is up out of the slope. We use that normal value to calculate the friction force acting on this object down the slope. In the question, we were given the coefficient of kinetic friction for the situation, 0,1. We substitute the value we found for normal into n. We solve, we find that the friction force is 16,97 newtons. We know it's down the slope because the object is moving up the slope, and when an object is moving, friction always acts on it in the opposite direction to its motion. So now we are in a position to calculate the net force acting parallel to the slope on this object. It's equal to 147 newtons, which is acting up the slope, minus weight's parallel component, which acts down the slope, and which is 20 times 9,8 times sine 30, minus friction, which we calculated just now, 16,97. So that gives us F net parallel 32,03 newtons up the slope. And this object accelerates under the influence of this net force. And so we can calculate what the magnitude of that acceleration is by dividing F net parallel by the mass of the object, which is 20 kilograms. And that gives us an answer of 1,60 meters per second squared. And we know that the direction of the acceleration must be the same as the direction of the net force, which was up the slope, so the acceleration here is also up the slope. This is our final answer that we were asked to calculate, so we underline it.